Hey there, you 12s. Here we're going to be looking at how to model compound interest with additional payments. So unlike the other exercises, you would have done investments where you get a certain payment back, but in this case, it's additional payments that you make to the principal. So let's have a look at this example here. It says, Nor plans to travel overseas. When she finishes her VCE, she has already saved $1,200 and thinks that she can save an additional $50 each month. So it seems like each month she has a plan of adding more money to the current $1,200 that she already has, and she plans to put a savings or into an account. Now that account pays an interest at a rate of 3% per annum, compounding monthly. So what that tells us is that she will be putting her money, $1,200, into an account which pays 3% per annum, compounding monthly. So she'll get interest on top of that. So by the end of, say, 1 year, she'll get obviously 3% extra on top of her $1,200, but keeping in mind that every month she's also going to add an extra $50. So what they want you to do is to model this investment as a recurrence relation. Well, recurrence relation, we need the V0, which is what you're starting off with. In our case, we're starting off with $1,200 that Nor had. And then Vn plus 1 is the model that you would type on your calculator that is recursive. That is continually where you press I'm just going to get my calculator up. Where you press the button and you press enter, 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 and it just repeats the process. So in our case here, 3% per annum, we need to change that rate. Okay, we need to change that rate to per annum, per monthly, sorry, so that we can figure out what the rate would be if it's being compounded monthly. So here we go, rate is 3%. And remember, this is per annum. So if you want for per month, then you would say it's 3 divided by 12%, and this is per month. Okay, so for per month. And we know that 3 divided by 12 is 1/4%, which is really just saying 0.25%. Or another way of thinking about it is 0.25 over 100. Okay, so I'm just going to write here. Remember, R times Vn and then plus D. R is the amount that you're gaining or losing, and so we write that as, remember, 1 plus the rate over 100 multiplied to Vn plus D. Okay, so what is our rate? Our rate was 0.25 over 100 multiplied to Vn plus, now our D amount is the amount that we're putting in. It's our additional payments. And so that is every month we're adding on an extra $50. So what you have here is a recurrence relation where we can simplify down to 1.0025. Yep. Multiplied to Vn and then plus 50. Okay, so that's what our recurrence modeling would look like, and essentially what we're saying there is that every month this is the extra interest. So remember, 1 represents the 100% of itself, and then adding on an additional interest, which we knew was 3% per annum, but really every month they're getting 0.25%. So that's why it's 1 plus 0.25% means out of 100. And that's where you get the 1.0025 multiplied to Vn and then plus 50. So on our calculator, if we really want to model this as a recurrence, this is what we would be doing. We'll be saying 1200 is what you start off with. So 1200, press enter, and then we know that according to the recurrence model over here, we know that it is timesing by 1.0025, and then we're adding on $50. Okay, so I'm pressing enter. That's how much you would get after 1 month. This is how much she would get after 2 months. And remember, every month she's adding on that $50 as well. So then 3 months, 4 months, 5 months. And that's the recursive formula when you're saying a recurrence. Okay?